Bernoulli's theorem. Bernoulli's theorem in PPL and CPL is one of the two concepts that are going to explain the phenomena of lift, along with Newton's third law of motion. In reality, it's much more complicated than this, but for PPL and CPL, we just need to know Bernoulli's theorem and Newton's third law of motion. In every class that I'm in, there's always some narc who's like, yo, actually, according to the NASA website, lift is much more complicated. And yes, it is, but for this course, this is as far as you need to get into it. If you're interested personally in learning more, then like go for it, because it's super cool. But for this course, this is all you need to know. Okay, so Bernoulli's theorem. So you know how the top, like if you're looking at an aerofoil, the top of the aerofoil is curved outwards a bit. It's kind of like a bit more circular and rounded than the bottom, which is flat. And since the wing moves through the air at like a constant speed, the air that's moving over the top of the wing has a further distance to travel because it's curved, it's got a positive camber, than the bottom does, which is simply just flat. Okay? So because the air moving over the top of the wing has a bigger distance to travel, the air's got to move faster than it does at the bottom of the wing to get there. So we've got faster air over the top of the wing because it's kind of curved, slower air on the bottom of the wing, okay? According to Bernoulli's theorem, faster moving air equals lower pressure. So we're going to have an area of low pressure on the top of the wing, and we're going to have an area of high pressure on the bottom of the wing. And now the lower pressure is going to kind of want to suck the wing upwards a bit. And this is kind of what helps us out with lift by Bernoulli's theorem. So we've got faster moving air on the top, creating an area of lower pressure, sucking the airplane up. Okay? They can ask this on your exam in a few different ways. So I'm going to go over some keywords with you. When you hear the word conservation of energy, or like the total energy in a system remains constant, that's always going to apply to Bernoulli. So whenever you get a question on your exam and you're not sure if it's about Newton's third law of motion or Bernoulli's theorem, if it asks about energy, it's always going to be about Bernoulli's theorem. Because scientifically, like the definition of Bernoulli's theorem is the total amount of energy in a system remains constant. For us, obviously, this means that an increase in velocity results in a drop in pressure. But like if you're not like inclined towards physics, you really don't need to know all this. Just remember energy, Bernoulli. And then faster moving air, lower pressure, causing the wing to get sucked upwards. And this is a bit of a simplification of it, but like this is really, if you know this, then you're going to be good for your exam. Oh yeah, okay, another key word could be pressure. So whenever there's a difference in pressure or high pressure, low pressure, and it's talking about whether it's, if it's asking you if it's Bernoulli's theorem or Newton's third law, pressure, Bernoulli. Energy, Bernoulli. Okay? So they might ask you like about some scenarios. So like, a common example that they use of Bernoulli's theorem is like if there's a big truck going by and you're like in a smaller car and you're driving, your car is going to kind of get sucked towards the big truck. And this is an example of Bernoulli because like as the truck goes by you, it's going to have a bigger velocity than your car. So it's going to have an area of low pressure around the truck and it's going to kind of pull you and your car towards it. You don't really need to know exactly how this works, but anytime that there's like an object getting sucked towards another object and it's not like actively being pushed or anything, this is an example of Bernoulli. All right, that's it. Sorry I haven't posted in a while, but I've been busy. Thanks to everybody who's like left comments and followed me and stuff. It's really cool. All right, bye.